the distance between the point P, which is -2, 3, and 1, and point Q, which is 4, -1, 5, right? So we have the distance equation that we'll use. So distance is equal to the square root, right, of your difference of your x, your y, your z, and all those individual squares. So let's say we do -2 minus 4 squared plus 3 minus -1, right? And that's squared. And then plus that additional z part. So 1 minus 5, and that's squared. Okay, and then we just simplify it. So we have -2 minus 4. Well, that gives me 6, right? So -6. And that's squared, plus, well, 3 minus -1 is 4, so 4 squared, plus 1 minus 5 would give me -4 squared, right? And that's still all underneath the square root. So simplify a little bit further, would give me 6 times 6 is 36, and because the negative's inside the square, it cancels the negative out. Right, plus 16 plus 16. 16 plus 16 is 32, right? And then we have, so 2, 6, and 8, 68. And then I could try and simplify that more, right? Because it could be, let's say, 2 and 34, right? So 2 and 17. So I could pull a 2 out. So 2 root 17. So that would be the distance between the point P and the point Q in a Cartesian plane, right? So now let's find the midpoint. The midpoint is going to be equal to, well, my x's added together divided by 2, my y's added together divided by 2, and then my z's added together divided by 2, right? So -2 plus 4 divided by 2, comma, my 3 plus -1 divided by 2, comma, and then the z part, right? So 1 plus 5 divided by 2, comma. And then don't change it to decimals, you can just leave them as fractions if need be. So that'd be 2 over 2, comma, well, 3 minus 1 is also 2 over 2, and then 1 plus 5 is 6 over 2. Oh, we got lucky. So we get 1, comma, 1, comma, 3 for our midpoint.